So yeah, thank you first of all to PyCon for the opportunity and to my company Loca for helping me get here. So today I'm here to talk about pushing the boundaries of Django managers. This is a solution that we first developed about 3 years ago, and we thought other people might find it interesting. So here I am today to share it with all of you. But first, I think we need to do some introductions, right? So who's this guy on stage? I'm João Vasconcelos. I'm a backend team lead at Loca. I've been working in backend for about 5 years now. Worked with Python, worked with Django, Fast API, also with other languages like Golang, Node.js. So kind of a little bit of everything, but Python was definitely the first love and still the best one, let's say. I think one of the main reasons I got into computer science and specifically backend was definitely the fact that I love to solve problems, love system optimization, love to learn new things. So if you have anything interesting like the previous talks, please share them. I always love to come to these conferences and hear about new projects and cool little things. So as I mentioned, this was first developed in a Django-based project. And as you can also probably conclude from the title of the presentation, it's definitely a solution focused on Django, but it can easily be ported to other frameworks. It can be used just with Python. So even if you don't use Django, I bet you'll find it useful, and you'll find ways of applying it to your own project. So bear with me, and I bet at the end you'll want to try it out. So I know we already talked a little bit about Django today, but I decided to include this part for those that never used it before. So Django is a Python web framework built for rapid development. I think someone in the morning said it perfectly, so it's kind of like a big cannon, and most of the times you want to kill a small ant. So it follows a batteries included philosophy in the sense that it literally has everything, its own ORM, its own templating engine, its own authentication management system. So it's pretty great, and it allows you to move really fast, especially at the beginning. Maybe you just want to do a quick POC, see if things are working. At its core, it follows a model view controller approach, which in Django, at least in the Django web framework, is usually called model template view, since the template is the way you're going to show the data to the user and also receive input from the user itself. So the Django ORM is definitely, at least to me, one of the best features. I find it really intuitive to use and really easy. And it's also one of the features that we're going to focus on today, since we're going to try to kind of push beyond it and find a solution that's a little bit more extensible. So Django Manager is a concept in the Django framework. It's the interface through which you can perform database query operations. So it's the interface through which you can use the ORM. By default, once you define a model, it already comes with its own default manager. So you have access to a bunch of operations from the start, from data filtering to updating, creating, deletion, so anything you usually need. But obviously, once your project starts to grow, queries start to get more complex, logic starts to get more complex, you might feel the need to also build your own custom logic and kind of encapsulate it in a single spot. And that's when custom managers come in. So Django also allows you to build your own custom managers, encapsulate your own custom logic, which I find pretty great. And right here we have a perfect example of that. I don't know if everyone can see, but at the end I'll also have a QR code that you can scan with the presentation. But the idea here, the main point is that the bottom you have the reservation model. Probably can do this right, yeah. The bottom you have the reservation model, and then we define our own custom manager, active reservation manager. And we also allow the user to use the default manager. So it's just an example, but sometimes you also want to kind of just redefine it. And through its name, I think everyone can already understand the idea here is that every time I retrieve a reservation, I only want to retrieve active reservations. So the logic gets encapsulated here on the get query set method, and it allows you to already have that set up. So like I mentioned, pretty great, pretty easy to use. I think it fits most of the use cases, but like everything, it has its limitations. And at least to us, what we start to feel is once queries start to get more complex, involving multiple joins, aggregations, subqueries. It might be hard to implement with the ORM, and even sometimes there's certain operations that the ORM just doesn't support. So customizing ORM queries for more advanced cases can become complex and also harder to extend, to read, to explain to other people. It also has a couple of problems. So one of them is the n+1 problem, which I bet a lot of people know. But for those of you who don't know, imagine you're retrieving a list of users and you have a related field that you're trying to access. And then for each row, for each user, you try to access it, and then Django is going to lazy load that for you, which means it's going to perform an extra query on the database. So maybe you're just not aware, and all of a sudden you have, I don't know, 10 more queries against your database, which can definitely degrade your system performance, cause unnecessary problems that you're not aware. So it's something that you need to be careful when using these type of tools. So how can we solve this problem, right? So this is also the question we asked ourselves within our project. We wanted to find a solution that could go beyond the ORM. So still use the ORM, but maybe in certain situations use also something else. And that's when we went on the lookout, and first we tried to just use plain raw SQL, right? So build our own SQL queries and then execute them, which Django is pretty great with that. It allows you to execute raw SQL in two different ways. So you can either use the raw method, which you can access to the manager, and it returns model instances. So in this case, it's good because it allows you to maybe build a more complex query, but you still have the benefits of the manager and the Django models, which will already do the parsing of the data for you. In situations where maybe you have a more complex query, it doesn't map one-to-one with your models, you can use the connection object directly. So it allows for that flexibility that in some situations you might need. And in our case, it was what we were using the most. So this solution allowed us to evolve a little bit more and kind of cross some problems that we had. But we also kind of quickly found a roadblock. And I mentioned a couple of problems here. One of them is definitely the fact that these type of solutions are can cause problems like the SQL injection problem. So obviously, the developer is responsible for making sure that you're only passing sanitized input into your queries. So it's definitely a problem which the ORM most of the times already protects you against that. And then another problem that we also found was the fact that once queries start to go, the complexity starts to grow, it also gets hard to manage that aspect. So I have an example in a few slides that I'll show you, and I think it will paint a good picture. But we got to a point where for more complex queries, we have kind of subsections spread across the functions, across the methods. And if you looked at it without executing it, it was hard to understand how everything kind of played out together. And it was hard also to understand what could I change, what could I not change without breaking something. So overall, it became difficult to read, maintain, especially as the complexity grew. So here we have an example pulled directly from the Django documentation of using the connection object. So like I mentioned, you can execute any query that you need, and as you can see, it's pretty simple. And over here, so I don't know if everyone can see, but kind of the conclusion that I want you to take from this is that this was just one section of our users query about 3 years ago. I kind of removed a few parts, anonymized the others also. But the idea is that this was just one section that could eventually be included in the main query or not, depending if a certain condition was true, if a certain situation was happening or not. So as you can imagine, as someone who just came into the project and you look at this, you feel like, okay, I'm not going to touch this because I'm definitely going to break something. And this is what we also started to find. So we started to find that, yes, raw SQL was probably the way to go, but we needed maybe something else to manage our queries and to help us understand better what we were actually doing. So once again, we went on the lookout for another solution. And that's when we found Jinja. So for those of you who don't know, Jinja is a templating engine usually used to generate dynamic HTML. So over here on the right side, you can see I have an example of a simple HTML template, and it's using a few operations that Jinja provides, so the conditional blocks, the for loop, etc. So Jinja, it's a really powerful tool, It has a lot of operations, so for those of you who don't know, I would advise you to go to the Jinja documentation and explore it for yourself. But from the top of my head, it supports inheritance, filters, supports macros, and much more that you can use. And we'll touch on a couple of operations today, during a few examples. But as you can already imagine, we're not going to use it to render HTML. We're going to use it to render our own SQL queries. So in order to do that, we'll need Python. We're going to use the Jinja 2 Python package. And we're going to use SQLite 3 just as our simple database to make sure that our queries are working. And for this example, I want you to assume that we have a users table, something pretty simple. It doesn't really matter, like email, name, ID. And here on the right side, you can see that we already have our base SQL. So this is our SQL Jinja template. You can see that we're retrieving the users from the users table, and we're using a few operations that Jinja provides, like the apply ID. So this allows, not the apply ID, sorry, the if block, which allow us to include the ID or not, so filter by specific user or retrieve the entire list. And then you can also use specific parameters. So in our case, we define the sort by and the sort order, so dynamically you can specify if you want to sort by a specific column, ascending, descending, you know it. So this one is an example of us using that template. I know it might be hard to see, but at the top what we're doing is we're importing our environment class from Jinja, and this will store basically all of the configuration aspects of Jinja, so where you're storing the templates, any options regarding the renderization of the templates. And then once we define it, we will be able to use the environment object, as you can see down here, and we're going to use it to retrieve the template using its name. And then once we have the template, we can render it, and in this case, we're just going to pass a sort by and a sort order. And at the bottom, you can see exactly the output. So I just had 3 users in my table. But as you can see, it's sorted by name, it's sorted ascending. So pretty simple, really easy to use. But this case was also small example. And like I mentioned, we won't have time to kind of explore everything that Jinja has. But I still wanted to touch at least on this include operation, which I feel like it's really powerful. So for this example now, let's assume that besides our users table, we also have an orders table. So it's kind of like an e-commerce application. The orders table has a reference to the users table. It has a total that the user spent on that order. And we have a custom way of calculating statistics about these orders. So as you can see, we're going to kind of encapsulate that logic here on our stats template, which I know this is pretty simple, but let's imagine in a real world case, it would be something more complex that we didn't want to repeat. And on the right side, you'll have our nested SQL Jinja template. And this is just an extension of the simple template that we saw before. And now what we're going to do is we're going to use the include operation, and we're going to include the stats template. So this is a parameter that we, just like we passed the sort by and the sort order, we can also pass at render time. And in this case, you need to specify the template name in order for Jinja to then include it here. And we're going to join against it just as we join against other subqueries, other tables. And then we can use the information as you can see at the top. So I have my user ID, I have my average that he spent in the total. And down here, just the same example, right? So I can still filter by a specific user. I can still sort by a specific column in a specific order. So we saw an example just using Python 3, right? So simple example. But like I mentioned, this came up from a Django-based project. So I still wanted to show you how to set it up in Django, which you'll see it's not that much different from the previous example. The big part is the configuration aspect at the beginning. And then we're going to use it the same way. So we're going to retrieve the template. We're going to render it. And then the output, which is just raw SQL, we're going to execute it. Here on the right side, you have kind of an example structure from a project I created for this presentation. So pretty simple also. It just has one application, the example application. But the important part is the settings.py, which stores all of the configurations for the Django project. And that's where we'll also need to configure Jinja 2. So what you'll need to do is we're going to go into our templates variable in the settings.py. Usually it has the Django templating engine by default. You can either extend it, right, and just add another option, Jinja 2. In my case, I didn't need the Django templating engine, so I just replaced it for Jinja 2. And besides also defining it, it is also important to point out the directories, right, where Jinja and Django can look for your templates. So in this case, it's stored inside of my example app on the managers folder, inside of my templates folder. So we talked about using custom managers for encapsulating common logic or custom logic, and that's exactly what we did in this case. So since we're going to do things a little bit differently, so we're not going to use the ORM, we set up our own custom manager. In this case, I call it user manager. I just have my users table, but you can imagine this maybe as a new base manager they can use to encapsulate this renderization logic, so it's common to every manager. We define our template engine as a cached property. We'll just want to retrieve it once, right? So it's our engine object. And then on the render template method, this is where we'll use our engine to retrieve the template using its name. And we're going to render it using some context. And the context is just what we saw before, right? So passing some data to fill parameters, to evaluate certain conditions, etc. At the bottom, we have our list method. And our list method is responsible for listing the users in this case. So it's going to use the render template method. I'm going to pass a template name, which in this case is the list SQL G2 stored inside of the user directory. And I'm going to pass some parameters, which in this case, since it's an example, I didn't explicitly define them, but I think you should definitely do that in order it's easier to understand, more verbose. And if no validation was done before, like we talked about regarding SQL injection and other problems, you should do it too. And then down here, so as we talked before, we can use the connection object, right? And that's what we did. Just execute the raw SQL output and return the results. So you have an example of me using that manager. So I imported the user, used the manager through the objects field, and called the list method. I just passed some parameters as before, the sort by and the sort order, so something simple. And down here, I didn't execute the query. I just wanted to make sure that the template was rendering correctly. So you can see I just printed the output and query looks fine. So if we had to execute it, it would work, just like the previous example. Okay, so we talked about two different solutions. We also talked about the fact Django already comes with ORM, so kind of have a lot of solutions to pick from. And we felt the same back then. So we ended up going with the Jinja templating engine. It's something we've been using for 3 years now. We don't use it solely, right? So we don't only use that, but there are situations where we feel like we need that, and we need to go beyond the ORM. But we also needed to evaluate its advantages and disadvantages. So I kind of also wanted to touch a little bit on that today, at least in our opinion, what are those? So in our case, we felt that it was easier to build dynamic queries. So as you can see, we can use for loop, we can use the conditionals to kind of manipulate how our raw SQL output will look like. So it was a lot easier to do that instead of just storing them in string variables across our code and then, depending if a condition was hit, using it or not. We also felt that by using the Jinja templates, it was easier to separate the actual definition of the raw SQL from the data generation validation that we would then include in our template to then generate the final output. So there's a clear separation of concerns. So if we want to make a change, it's easier to understand where to do it. And overall, it's easier to understand the project itself. And also related with this, readability, which was definitely a must. So if you remember what I mentioned about solution number 1, just using raw SQL, we felt that it was hard to extend what we already have. It was hard to understand what was there, also explain it to other people. So overall, we just felt that by using this, we're making a step in the right direction and making it easier for everyone in the team to understand what's exactly in these queries. Disadvantages. So SQL injection risk continues to be one, right? Because in the end, this is just a different way of generating the raw SQL. We're still using raw SQL, so you need to be careful with the data that you're passing through your templates. So the developer is responsible for sanitizing the input, doing the proper validations, everything that we already know. Storing complex logic in the templates can also get out of hand. So, and what I want to kind of emphasize with this is that this is definitely a better solution, in our opinion, to have more complex queries and to build more complex logic. But obviously, there's limits to it, right? And that's what I think everyone needs to keep in their minds when developing a new query or extending them, that sometimes it might be just too big, it might be hard to understand, maybe it's better for a separate operation. So Jinja also suffers from this, this solution also suffers from this. So just be careful with the amount of logic that you're including in a single query. And finally, the limited debugging support. So this is something that, at least to me, I felt a lot in the beginning. I feel like there's kind of a learning curve to it, in the sense that in the beginning it might be hard to understand, for example, if you're getting a specific error in your raw SQL output when you're executing it, where it matches on your template, and trying to understand if it's template definition problem, if it's related with the data that you're passing to it. So I think there's definitely a learning curve to it to try to understand how to solve the error. But once you overcome that, I feel like it definitely gets easier. So I already presented a couple of solutions, but I wanted to present more, right? And I want to also thank my colleagues at Loca, because before coming here, we kind of did a small internal presentation with this topic, and they mentioned some really cool alternatives that I also wanted to talk about today. One of them is the Django unmanaged models. So it's a pretty great feature provided by Django. So once you're defining your model, you can set it as unmanaged. And what that means in the end is that once Django is trying to look over your models, try to understand which migrations it needs to build and execute with your database, it will skip these unmanaged models because it assumes that you're the one managing it, right? So this is great for situations where maybe the table is already there, or you might have built a materialized view, and then you can use one of these Django unmanaged models to map one-to-one with your materialized view. So this allows you to, in the end, use the ORM to retrieve the data, right? And it does kind of the parsing automatically for you. It parses the data to the model. But it also allows you to build more complex queries. Maybe if you're more used to using raw SQL, it's just easier to also build a materialized view. So definitely an alternative that I feel like everyone should explore. And then query builders, which I feel like it's something very common in every language. I'm going to be honest, in Python I never used it, but I found PyPika to be a really well-known one. And the Django query builder is also another package, I think, built specifically for Django, but PyPika, I think, definitely takes the throne. It was the most well-known one that I found. In the end, this is just a different way of building the raw SQL, right? Just as Jinja is also a different way of building the raw SQL. What I feel like this option is very good at is, in the end, you're using Python classes, you're using Python methods, so it might be easier for people that are most used to using Python than raw SQL to manipulate. And once you have your query ready to go, you can just pass the output to the connection object, just like we did with output that came from the Jinja template renderization. Okay, so that GitHub logo was supposed to be on the final slide, but let's assume this is on purpose. So we talked a lot about different solutions, right? Alternatives. We talked about also using the ORM. And I feel like in the end, it really depends on the team. It really depends on the people. It depends on the expertise of the people around you. Some people might find the ORM to be more than enough. Other people might find the raw SQL does the job. In our case, we found the Jinja templating engine to be a really good solution when we needed something more. It's something that we started to use about 3 years ago. We still use it today. We refactored old queries. We still build new ones with it. So I would advise you to just try it out, see it for yourself, try the other options too, and maybe you'll find the right solution for your project and for your team. Thank you. You have the QR code that I mentioned if you want to scan and you need the presentation.
So, thank you, João, for your talk. Questions?
Thank you. This was very interesting. I have just a curiosity because I never used Jinja before. So how does it work? So does it at startup does it like read all the templates and keep them in memory, or does it like read the templates at every request basically?
That's a really good question. I'm gonna be honest. I'm not too sure. I know that you at startup specify the place where it should look at, right? So you define the directories, and you also have other types of loaders, especially with Jinja specifically. So I'm not too sure if it loads them dynamically as you request, or if it kind of keeps everything in memory, and then once you request, it's already there. I would have to check.
Thank you. Thank you.
Welcome. Thank you.
Oh, yeah.
Answer is you don't use cached templates because in settings you provide simply templates loader without wrapping in caching templates. In this case, it's loaded on every request. Question only, no problem. Question only about solution. Why you use context manager with connection? Why not to put the rendered template directly in row command of manager? Because you have already text and you can choose the method row and the text is rendered template.
Yes. So we've used that in a few cases where you want to map one-to-one to the model, right? But in situations where it's a more complex query and it doesn't match one-to-one with the model that the manager corresponds to, we end up just using the connection object, right? Because then you won't be able to use it because the data doesn't correspond solely to the model. Maybe there's some other information from other places or calculated in the moment.
Any more questions? Do we want to? Okay.
Hey, João. Thanks for your talk.
Thank you.
I like the creative use of templating to add modularity to SQL. Okay, SQL is very powerful and verbose and non-modular. Now, you call out on the SQL injection thing, which is a very serious thing. Okay, so if I had to choose, okay, SQL injection, it's not an option, bye-bye, thanks. But you had a short example, and I'm not familiar with Django code, okay? We have the minimal Django thing with a simple SQL query, and the SQL injection, now further back, further back, further back, further back. It was one of your first slides with code. I think it was Django. Back, 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 meant further back. Like the minimal example, further back. This one? Okay, this one. And this is using, if I understand your terminology, this is raw SQL for you, isn't it?
Yes.
Okay, this doesn't suffer from the problem of SQL injection. This has no problems of SQL injection. So this can be applied to the method, to the idea of the templating, right? Do you agree or not?
So in this situation?
There's no SQL injection problems in this code, okay?
In this situation, no. I would say no.
And this is the kind of, the templating idea that you're suggesting is building that string there, correct?
Not for this situation, right? So this is something pretty simple. I pulled this from the Django documentation.
Sure, it's executing a SQL query.
Yes.
That's what this does.
Yes, but like I said, we didn't use this solution for everything, right? So I feel like you shouldn't use it for every single situation if it's more dependent on the motivation. If you have something more complex, it needs to get managed like that.
My point is, but I'm not familiar with Django. My point is, you're giving the database engine a SQL query, okay, and parameters. There's self.baz there.
Yes.
Right? That's the key to SQL injection protection.
Yes.
Can't this approach be used with your, because the difference in my mind is that your SQL, the SQL you're building is more clever. You're using Jinja to come up with a more manageable, complex, and long query.
Exactly.
But the query arguments or parameters, they can be passed, I suppose, pretty much as in this example.
They could.
Can't they?
But there's situations where you can't, right? For example, if you're using the conditionals, right, and other operations.
Yeah, you'll need to know how many of those you need to pass.
And those ones you need to pass to Jinja itself, so you couldn't pass it this
Yeah,
way.
it's non-trivial, but there's a solution for that. You need to manage that, but because you can't talk tolerate something. Hey, yeah, there's SQL injection problems, but yeah, managing the query is easier.
But,
For
but
me,
let me mention,
it depends on your
we
solutions.
also don't
of course.
tolerate it,
Yeah, of
obviously.
course.
And this is just pure, simple examples, but we don't execute anything that comes. There's
I
proper
love your idea.
validation.
I love the
you
idea
know.
of using templates, okay? But it kind of feels that it needs to be extended with a bit of metadata so that you know with this template output, rendered template, I'll need to feed it these parameters and go. So you need an extra
Yes.
engineering thing around that to solve the problem. Do you agree?
Totally agree in that case. Totally
Okay,
agree.
okay.
And I also want to mention, like I mentioned, this is a pretty simple example.
Sure.
And those are aspects that we also define. Imagine for every single manager, you have specific methods that will return the parameters that you should pass to it. There's
There you
proper
go.
validation.
Yeah.
Obviously, I didn't have time to touch on everything, but
So I
thank
just
you.
wanted to, because I'm not familiar with the Django details of going with giving it raw queries, okay? I might have been misunderstanding, but now we're on the same page. Thanks.
No, thank you.
Hey, really nice idea.
Thank you.
Can you just the example that you gave with the Jinja template? I think it was a very simple example with the users one. I wonder how do you, for instance, translate the previous slide? If you can go back, please. The complex one, yeah. How would you make this SQL query that in raw SQL or even using Django raw method that is fast, although not very readable, I agree. How would you translate this to the Jinja example? Because I know that saying that this is complex, I agree it is, but I wonder how the new solution with the Jinja template would make this more readable than it is.
That's a really good question, and thank you. I think so. This just small snippet isn't a really good example of what Jinja could do with it, right? Because if you just pass this to Jinja, you're just passing the same parameter, so it will look really similar. Maybe a difference in syntax because you need to those parentheses, right? But the big difference, if you would look at the full method in the way that we manage this, right, in terms of understanding if this part should go into the main query through a condition, pulling data from other places to understand if you should retrieve a specific aspect for the users, that's where Jinja kind of, in my opinion, wins. Because you can define that using the if blocks, using the for loops directly in the template, which I know this example doesn't illustrate that. So imagine that besides this, you add more variables storing other parts of your query, you add conditions kind of deciding them if they should go there or not. And if you move that to Jinja, all of that would be defined there, and then you're just passing the data that it needs to decide, okay, I'm going to include this, I'm not going to include that, etc.
Okay, okay, thank you.
Thank you.
Any more questions, suggestions? Nope. To you, João.
Thank you.